In this video, we're going to teach you how to use the activity series of both metals and the halogens for single replacement reactions. So a big important factor that you need to realize is that we only use these two activity series for single replacement reactions. That's it. Don't use them on any other type of reaction. Now, the way that they are used is that metals that appear high on the list have the ability to bump out anything that comes below it on the list. It's best illustrated by using an example. So if we look at an example for a metal, let's just take aluminum that's going to react with hydrochloric acid. Now, in this example, we know metals are usually positive forming ions. So they're going to try to replace the positive part of HCl, which should be the H. That's what's going to be tried. Positives will replace other positives because they're attracted to the negative partner. Now, what we want to do is we want to identify where we can find each of these two things on our list. So here we find aluminum, and here we find hydrogen. Now, aluminum is above hydrogen in the list. So it has the ability to replace hydrogen. So as a result, hydrogen gets kicked out of the partnership and is left on his own. Now when hydrogen's by himself, you'll remember he's one of the 7 diatomics. So we've got to write it as H2. And then we're going to pair up the aluminum with the chlorine. Now remember, aluminum lives in column 3A, so it has a positive 3 charge. Chlorine lives in column 7A, so it has a -1 charge. So to correctly write its formula, we would want to write AlCl3. The reason aluminum could kick out hydrogen was because aluminum was above hydrogen on the list. Now, the only thing left to do is balance this chemical equation, which I know that each of you are probably capable of doing. And so I would ask that you try that on your own if you want to practice it. But if you want to just check your work here, you should be able to get those coefficients when it's balanced. Now, how do we read this when it doesn't work? So let's erase our red arrows, and let me give you another example of an element trying to react with a compound. So I'm going to erase the reaction we just did, and now I'm going to give you a different example. I'm going to give you silver reacting with copper 2 nitrate. And we're going to see if that reacts. Now again, silver is a metal, and he's going to try to replace the other metal in the compound, copper. So what we want to do is we want to find both silver and copper. Now silver is trying to replace copper, but because silver is lower on the list than copper is, it won't be successful. So this has no reaction whatsoever, and usually we just indicate that by writing NR for no reaction. Now, it works very similarly for the halogens. So I'm going to show you an example using halogens. Let's take something like fluorine gas, which is one of the 7 diatomics, and let's react that with NaCl. Now, in this case, you have to examine what these elements are trying to replace. So fluorine is the single entity, and he's going to try to replace, because he's a nonmetal, he's going to try to replace chlorine, which is also a nonmetal. Now let's look at our activity series for the halogens. Fluorine is on the top of the list, and chlorine is right below it. It's because fluorine is above, this reaction can happen. So chlorine is going to get kicked out of the reaction and left on his own. Chlorine is one of the 7 diatomics, so we have to write it as Cl2. And then to pair Na, which lives in group 1, and fluorine, which lives in group 7, to pair them together, we write NaF. And again, the only thing that is left is to balance the equation, and we can do so by putting 2's in front of the NaCl and the NaF. Now, if we use a different equation, something like, let's do Br2 reacting with HF. Okay, again, Br 2 is a nonmetal. And now in this case, he's going to try to replace the element that he's most like, which is fluorine. He's going to try to replace fluorine. But let's look at where they live on the activity series. Bromine is below fluorine, so this reaction cannot happen. Bromine is not strong enough to push fluorine out. So that is how you use the activity series for both metals and nonmetals. Hopefully that helps you a little bit with single replacement reactions.